Welcome to an introduction to the TERESA project. It will present an overview of the main concepts and goals of the project. TERESA assumes that there is a separation of roles among engineers. The objective of the pattern engineer is to create reusable subsystems. He develops patterns for security and dependability using pattern editing tools. They allow for the creation and storage of engineering artifacts, which are the blue balls in the picture. The objective of a pattern integrator is to ensure that the patterns can be used in the development of applications in a given domain. She uses pattern instantiation tools which transform the repository artifacts in a form that is adapted to the application development environment, which are the red balls in the picture. These systems are called resource-constrained embedded systems. They use limited computing resources and have stringent cost constraints. For example, sensors, meters, and appliances use components that cost around €1. Resource-constrained embedded systems are important because they are often part of critical applications, such as a car braking system, a signaling system, and a fire detection system. Resource-constrained embedded systems must increasingly integrate additional features for security and dependability. For example, a car must include a secure communication system to download software, or a railway system for distance detection must receive information that is reliable, or a meter must communicate securely measured data. The development of such features requires specialized expertise and skills. The cost of designing such features from scratch could easily exceed the cost of the rest of the system. For example, the development of a security component for an electricity meter requires expertise in security that is seldom available in the metering industry, and it requires expertise in the engineering process and the validation practice of metering, which is not always available in the security and dependability community. The name TERESA stands for Trusted Computing Engineering for Resource-Constrained Embedded Systems Applications. TERESA proposes a solution based on the reuse of software subsystems that have been pre-engineered to adapt to a specific domain. TERESA's key innovation is to support the reuse of independently developed security and dependability features without having to re-engineer them. Thus, the overhead for integrating a security and dependability feature would be just a fraction of the expected overall development cost and time. In the example of a security component for an electricity meter, first, a security expert develops a security subsystem called a pattern. Next, a TERESA software engineering expert adapts the pattern to engineering reuse. Then, a meter development environment expert adapts the security pattern into a version that is usable in the metering system development environment. And finally, a domain-specific engineer, in this case the meter engineer, reuses the resulting adapted system in his development environment. The security expert focuses mainly on patterns development elements or development artifacts in an engineering process. The software engineering expert ensures that other engineering artifacts are available throughout each phase of a domain-independent development process. He also adapts them for the meter domain-specific process. The meter development environment expert transforms the artifacts into a version that is adapted to the meter development environment. In summary, the activity of creating the blue artifacts is performed by the security engineer and the TERESA software engineer, who can also be called a security and dependability pattern engineer. He uses a number of tools, grouped in Toolset A in the picture. Those tools, based on model-driven engineering techniques, create information that is stored in an engineering repository. The activity of creating the red artifacts and accessing them is performed by the Domain Development Environment expert and the domain expert, who can also be called a security and dependability integrator. He uses a number of tools, which are grouped in the tool set B in the picture. Those tools, based on transformation techniques, create information that is usable in a specific development environment, that is, the development platform. TERESA will develop a toolset A to create a reusable subsystem. The toolset will support two domains, the railways domain and the metering domain. TERESA will also develop a toolset B to allow reuse in two specific development environments, one for a railways use case and another for a metering use case. By developing a flexible engineering approach, TERESA will contribute to the establishment of security as an engineering discipline in the area of embedded systems. TERESA is a project supported by the Framework 7 program of the European Commission.